These video lectures will help you learn more about redox or reduction oxidation reactions, particularly on how to balance them. I think learning how to balance redox reactions not only helps you achieve the goals or the objectives found in your syllabus, but it will also integrate several concepts that you already know in chemistry. Before we proceed, let me give some examples of redox reactions. Have you ever noticed the browning of the flesh of your apple? So once you cut the skin, once you peel the skin away, exposing the flesh, and leave it on the counter, after some time, you will notice that it has this brown color. So from the white to the brown color. So this happens because of oxidation. So the molecules found in the flesh of your apple undergo oxidation. Why? It's because of the oxygen in air. So yes, the word oxidation, that process, has something to do with your oxygen molecule. Have you ever heard of glutathione, the one that is marketed as whitening pills? The whitening is actually a side effect. The main purpose of glutathione is an antioxidant. Antioxidants are molecules that prevent the oxidation of molecules in our cells, like the DNA. See, the sunlight is energetic enough to cause oxidation in our DNA. And this is bad because the oxidation can introduce mutations in our DNA. But if we have glutathione in our cells, it is the glutathione that will sacrifice itself and block the damage on the DNA caused by sunlight. And finally, another example of redox reaction is found inside our cells. If you know ATP, this is what we call the energy currency of the cell. It's the molecule that carries energy from one area in the cell to another area, and it makes possible the biochemical reactions that sustain life. Without ATP, there is no life. Now, this ATP molecule is generated inside the cell, particularly in the mitochondria, through redox reactions. So I only mentioned 3 examples, but there are a lot of redox reactions taking place around us. Most of them we don't notice. So what are redox reactions? Redox reactions are what we call electrochemical processes. So it's not just a chemical reaction. If you remember, we define a chemical reaction as the rearrangement of atoms. But in redox reactions or electrochemical processes, it's not just the rearrangement of atoms, but there is also electron transfer involved. That is why we have the electro there in the name. So again, redox reactions involve transfer of electrons. And because there are charged particles involved, this also has something to do with electricity. So yes, there are redox reactions taking place inside your battery. That is why it can provide voltage to a toy, for example, or your remote control. Now, the two processes, we have the oxidation and the reduction. So redox reactions, the name redox comes from two words the reduction, and the oxidation. So it is often shortened to redox. So they are called half reactions because one of it is just half of the whole reaction. An oxidation reaction cannot happen by itself. Likewise, a reduction reaction can only happen if there is a corresponding oxidation reaction. So the definition, when we say oxidation, your reactant loses electrons. That is oxidation. Now it loses electrons. Where do the electrons go? They go to the molecule that undergoes reduction, because reduction is a process at which your molecule gains electrons. So you now see why these two processes cannot take place without the other. So reduction cannot take place if there is no available electrons for the molecule to gain. The electrons will come from the oxidation process. So again, an oxidation reduction or redox reaction always occur together. Now, the reactant that undergoes oxidation is often called the reducing agent. So if compound A, loses electrons, meaning it undergoes oxidation, then compound A is called the reducing agent because it allows the reduction of the other reactant B. On the other hand, the reactant which undergoes reduction, in this example it's B, this is called the oxidizing agent. So it is the agent that causes the oxidation of letter A. So it's opposite. Again, the reactant that undergoes oxidation is the reducing agent, and the reactant that undergoes reduction is the oxidizing agent. So an example is if we have zinc. So if you have a piece of metal zinc, when it undergoes oxidation, it becomes zinc ion. So you notice it now has a positive charge because your zinc, initially neutral, give off 2 electrons. So the charge now is positive 2. Now, if this solid zinc is placed in a solution of copper 2 ions, what happens is that the copper 2 ions in the solution gain the 2 electrons coming from the zinc, and this leads to the formation of solid copper. So if you imagine that you have a solution of copper 2 ions, which is its color blue, and you place a piece of zinc metal in this solution, you will notice the formation of red precipitate or some red solid in the solution. And after some time, the color blue will become colorless. Why is that? It's because the copper 2 ions are being reduced to solid copper. Copper 2 ions are blue in solution, solid copper is red. So redox reactions are actually fun to watch in a laboratory because of these color changes and formation of precipitates. So there is a famous mnemonic used to remember all of these concepts. So we have the Geroa and Leora. So I call these the couple of redox reactions. So Geroa means the reactant that gains electrons undergoes reduction and it is the oxidizing agent. Leora, on the other hand, stands for the reactant that loses electrons undergoes oxidation and it is the reducing agent. So you can remember these mnemonic to make it easier for you to understand the meaning of oxidation, the meaning of reduction, and for you to be able to identify the oxidizing agent and the reducing agent in a redox reaction. And finally, here are more examples of redox reactions. Rusting is also due to a redox reaction. So it's the iron in your metal that undergoes oxidation. The oxidation takes place in the presence of water and again oxygen. So once your steel is exposed to some moisture and air, after some time, it will develop rust. And this rust is actually ferric oxide. So this Fe2O3. Another example, again involving zinc, is the reaction of zinc metal with hydrochloric acid. So if you can get your hand on some zinc, I believe nails, the coating of your nails, yung pako, that is zinc. So try dipping uh, a nail in muriatic acid. So of course, wear your proper protective equipment like gloves and goggles. Try dipping nail in muriatic acid. So you have hydrochloric acid in muriatic acid. And you should be able to observe the formation of gas or bubbles. And this is due to H2 or hydrogen gas produced from the redox reaction of zinc metal and hydrochloric acid.